Now we will study the concept of energy level. The electronic configuration for silicon and germanium are like this. Silicon has got 14 positive charges in the nucleus and 14 electrons distributed 2, 8 and 4. In the outermost shell 1, 2, 3 and 4 electrons are there. In germanium similarly the configuration is 2, 8, 8, 4. In the outermost shell there are 4 electrons. So whether it is silicon, germanium, the outermost shell is having 4 electrons, that is semiconductor. Now these electrons are having certain energy level which we have done in the chapter of atoms. Now all these electrons, when they are in isolated atom, in one atom, then their energy levels are almost similar. There has to be certain difference, but almost they are similar. But when we make crystal form of the atoms, here are atoms, then they come very close to each other. Atom come very close to each other, and when atoms come very close to each other, then their energy levels change. This is isolated atom and this is crystal form. So in the isolated atom, the energy of all these 4 electrons is almost same. But in crystal form, there is a redistribution of their energies due to various forces applied by the other atom charges. So now we find that in the electrons of atoms in crystal form, there are 2 categories of energy levels. What does that mean? There are some electrons which can do the work of orbiting around the nucleus, and whenever there is a need for combination with another atom in the crystal, then they will do that combination work. And this is an atom. We are concerned with the outermost shell, outermost orbit. So I am talking about the 4 electrons which are here. We know for valency fulfillment there should be 8 electrons moving around it so that it will remain stable. Here is another atom. It is also having 4. Now we have studied that this one electron which is moving like this and will go this way also, and this one electron from this atom will also do this duty. So this will share one with this will share one with this atom, and now they have 5. Similarly, it will share one with this, one with this, one with this. So this one atom shares one electron with this, one with this, one with this, one with this. Now all are sending one electron here. So it has fulfilled 8 electrons circling around here, and now it has got a stable nature. This is pairing of the valency. So electrons make pair here, and because of this pairing the valency is fulfilled and they have a stable nature. Now this electron which was moving around this place is having certain energy. This energy is not only used for this but is also used for moving around this. That much energy it has, not more than that. There may be few electrons which have received energy more than this. How? That is by heating. If we give heat to a semiconductor, it receives thermal energy, and that energy, when it is received by this electron, what it will do? Its usual job is rotate here, rotate here, rotate here, rotate here, and now it has got energy. Now it has got energy, so it will go like this. Come out from this. Come out from this duty of making valency bond fulfilled. Now it is no more doing the job of valency. What it is doing? Nothing. It comes out. It will come out from here and somewhere here, somewhere here, somewhere here, and it keeps on moving with a very high speed because it has got energy due to high temperature, and that is known as thermal energy, and it has got velocity due to that energy. We will call that thermal velocity. Now this electron is free from the duty of fulfilling valency job, so we call it free electron. So free electron, and this electron can do only valency fulfillment job. It is not having energy equal to free, so that it can become free. So this we call valence electron. Whenever there is a crystal formation, all the electrons divide themselves with two type of energies. Either they have a limited stock of energy, which we call valencing energy, and with that they will only do the job of fulfillment of valency, pairing. There is another group of electron which has got more energy. They are not doing the valency fulfillment or bonding work. What do? They move around with high speed within the crystal. But whenever there is an application of electric field, whenever we apply an electric field across this, then these electrons experience a force due to this electric field, and they start drifting towards this positive charge. Are they not drifting? Are they not drifting? Answer no. They are so close to positive charge that these electrons which are doing valency fulfillment, they do not drift. So who drifts? The free electrons, because they have no protection of this positive nucleus which will keep them binding with them. They have come out of the binding, and now they have come out of the binding. This positive do not protect it, and they start drifting in the presence of electric field. And when they start drifting in the electric field, we say current is flowing. We have learnt it in electric current chapter, and we call it drift velocity. So these are the free electrons which help in conduction of electricity. What is their quality? What is their property? They are free because they have got larger level of energy. So more energy makes them free, and because of that they are able to move in the electric field and they form current. So for current conduction, which type of electrons we need? Free electron or valence electron? Yes, answer is free electrons. Who has got higher energy? Free electrons or valence electrons? Answer, free electrons have got higher energy. Okay. Now, how many energy levels can be there? Answer, for each atoms, for fulfillment, there are 8 places. There are 8 places, and in semiconductors, silicon or germanium, The 4 places are filled with electrons and other 4 energy level places are unfilled. There is no electron there, but places are there. You see, this is coming here, this is coming here. So, there are 8 energy levels possible in one atom. There are 4 energy levels engaged in one atom. Why 4? Because they have 4 electrons in the outermost orbit. But level, how many? 8 possible levels. 4 engaged. Now if we have a crystal, there are total 8 n possible levels and 4 n energy levels. This is what happens in a crystal of semiconductor. So now there are 2 groups that also we have learnt. Now what happens at a certain distance, the natural distance between the atoms, when they form the crystals, there is a redistribution of forces. In the redistribution of forces, what we observe finally, that there are clear-cut 2 categories of energy levels. Electron, this level of energy, height shows the energy. There is one electron having this much energy, another this much, another this much, this much, this much, like that. These are energy level whose total number is 4n levels. And the conductor who can conduct electricity has a higher energy level. How much is energy of that? This much, or this much, or this much, or this much, or this much. And these are also how many levels? 4n levels. The free electrons, when they have energy, their energy will be this much, or this much, or this much, this much. The electrons which are doing only valency fulfillment job, making the bonds, but they do not leave their atoms because they have less energy. They have got only this level of energy and they are doing only valency job. So all these levels together makes a band, a strip, a band. So this we call as valence band. This is energy level diagram. In the energy level diagram, there are 2 bands. One band is known as valence band. This valence band has got, what do we call these lines? Energy levels. In one band, how many energy levels are there? 4n. Because we know how many energy levels are there total. This 8 energy level in one atom, and how many atoms have combined? N atoms. So 8n possible energy levels. And we have seen that in a crystal there are clear-cut 2 categories. One category which can do only valence fulfillment, one category of electron which can do conduction. That is quite high. And this band, now we will call it conduction band. This is one conduction level, other electrons conduction level of another electron. All the electrons which are having this much energy, this much energy, this much energy can conduct electricity. These electrons cannot conduct electricity. Now tell me, in a crystal of n atoms, how many free electrons are there? Answer, every atom has got 4 electrons and there are n atoms, so there are 4n electrons total. How many possible energy levels in valence band? 4n. How many energy levels in conduction band? 4n. So if all the electrons decide that they will not conduct electricity, they will do only job of fulfilling valency, only bonding job, they will be at low energy. Can it be possible? Answer: yes, it is possible. Because how many levels are there? 4n. How many electrons are there? 4n. Every one will engage one electron. It is just like a cinema hall which has got a lower class with 4n seats, and there is a balcony with 4n seats. The total visitor to the cinema hall are 4n. They distribute themselves, some here, some here. Suppose all of them want to sit in balcony, is it possible? Answer: yes, because there are 4n seats. All of them decide to sit in the lower class, again possible. Similarly, here, how many levels we have? 8n total levels, and how many? 8n possible energy levels, and how many electrons are there? 4n electrons are there. So all the electrons, if they decide, if they want, they can be here, they can be here, or they can distribute themselves. Normally they distribute themselves. There are cases in which all of them are here. Okay, so there are clear-cut two bands. Now you see this is a gap. Why there is a gap? Because we find that electrons who are doing valency are not having energy more than this. This is the maximum energy an electron doing valency job is having, not more than this. The minimum energy required for an electron to be a free electron, minimum energy required is this much, this. Then only it will act as a free electron to conduct electricity, otherwise it will not be able to conduct electricity. Then what about the electron which is having this much energy? This. Answer: we have not found such electron. Such electrons do not exist. There is no electron having this much energy. So we call it forbidden band. So no electron is having this energy. Either electrons are having this energy or electrons are having this energy. This is forbidden band, and there is a clear gap between the two, and this we call energy gap. That is EG. It is a very important term, very versatile term. This electron can do only valency job, it cannot conduct electricity. If it gets energy, if I give it energy, how much? Equal to energy gap. Then its energy becomes this, and now it can conduct electricity. It will leave that valence job and it will conduct electricity. So what we have studied is that in a single isolated atom, the energy of electrons may be equal, but when they form crystal, there is a redistribution of energies and their energies become separate, but there are clear-cut two type of energy bands. One group of electrons are carrying energy which can do only valency fulfillment, and that is bonding work. And there is another group of electron which have got higher energy. They have left the orbit, they are moving in the crystal, and with the electric field they can conduct electricity. We call them conduction electrons, and their energy levels are in the conduction band. This high energy level is for the conduction band. There may be a blank space between the two measurements because no electron possesses this much energy. Either they have this lower energy or they have this higher energy, so we call it forbidden band. And this gap is known as energy gap. For one electron which is doing the job of valency, if we want it to conduct electricity, we have to give it so much energy, Eg, that is energy gap, we have to give it so that it will jump to the conduction band and then it will be able to conduct electricity and the material will become conductor. So, this is energy gap method of understanding conductivity. Now, on the basis of this, we can again classify the material. How we can classify the material on the basis of energy gaps? See, I will make this diagram 3 times, one for metals, one for insulators and one for semiconductors, and that will make you understand that what is the difference between them. That is one way of classification, and this is the way we are going to pursue in all our chapter. Thank you.